Hey, it's Miss Reese, and we're looking at lesson 6.1, slope triangles. So if you notice here, we have this triangle on our diagram. We call that a slope triangle. So remember, slope is like our change in y over change in x, vertical change over horizontal change. So the slope of this line, we could see, is a vertical change of 1, a horizontal change of 5. What we want to try to create is another triangle that has the same slope. So we're creating another slope triangle. Now it's going to be kind of an overlapping triangle. Instead of going up 1 and to the right 5, we can go up 2. So this length here being 2, and then this length here would be 10. Sorry, my triangle's not perfect there. So that slope triangle 2 and 10 would be similar to that slope triangle of 1/5. It's along the same slope of the line. And we're going to create at least 3, so let's try one more. We'll do one more together, and then you can try one more independently. Another slope triangle, instead of going over, so we first went over 5 up 1, and then we went over 10 up 2. We could go over 15 and then up 3. So 3, and then imagine that whole entire baseline here would be 15, 3 and 15. That would be another slope triangle along that line. You're going to create at least one more, okay? And then we want to look at the triangles in terms of similarity. Why would they be similar to each other? Well, you notice here they have this 11 degrees. That would be the acute angle. And then they all have this right angle here in the corner. We have the horizontal and vertical line making a 90-degree a right angle. So we know these triangles are similar because they all have two angles that are the same. So remember, our similarity reasons would be side, 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 side angle, side, and angle, angle. Well, the easiest way out of those three to determine why these triangles are similar is because of angle similarity. They both have an 11-degree angle and a 90-degree angle. Technically, we could also use side angle side. If we wanted to use side angle side, like in the first triangle, this would be a 1 and a 5. We have that right angle in between that, okay? And then with our enlarged triangle, it's not quite to scale, but we have a 2 and we have a 10, and there would be the right angle between that. So we could also use side angle side, and then you can see we have a triangle with 3 and 15. All of those are going to simplify to our same value. Okay, so we want to confirm that conclusion by writing the slope ratio for each triangle as a fraction. So slope ratio is change in y over change in x. So let's pretend this is a 1, this is a 5. Our slope ratio for that would be 1 over 5. Oops, there we go. So the first triangle, the slope ratio is 1/5. Our next triangle that we created was 2/10. And then I also created another triangle, 3/15. So I'm going to put equals between these. You should have one more that you created, a slope ratio that would be similar. And then we want to put these all in decimal format. So really just getting out your scientific calculator if you want to get out a Desmos Scientific. I would just put in 1/5. Well, what is 1/5? If we put in 1 divided by 5 as a decimal, that is 0.2. You want to confirm that. It's the same if you did, like, for example, 2/10, that's also 0.2. We can put in another one, 3/15. That's also 0.2. So check all of your ratios. All simplify, all equal 0.2. Now we're going to look at, okay, if we have different measurements along our slope triangle, and it's going to be that same slope triangle with the 11 degrees and 90 degrees, we want to find some of our missing sides. So let's just draw kind of a visual of that slope triangle. We have our 90 degrees here. We have our 11 degrees here. It's similar to the triangle that we already started with the 1 and 5 here. But again, we're not using 1 and 5. This time, we're given that the change in y is 6. That's this value here. This is a 6. What we want to figure out is this change in x, this value here. So when we divide these two numbers by each other, we want them to be equal to that 1 over 5. similarity. So I'm just going to draw my original slope triangle, the simplest one. This was my 90 degrees, this is 11, this is 1, this is 5. So I'm going to say 1 over 5 needs to be equivalent to 6 over x. Okay? So 1/5 equals 6 over x. And from here, we would just multiply our cross products with each other. Okay, so first cross product would be x times 1. That's going to be x. Next cross product would be 6 and 5, so that would be 30. X is 30, so that would be this measurement here. And that makes sense. 6 over 30, that's going to simplify to that 0.2 or 1/5. Okay, and for this last one here, let's draw a slope triangle. And this time we've got our 90 degrees here, we've got our 11, and this time our change in x is 40, and this you're solving for y. So you can still use this slope triangle here, 1/5, 1 over 5 equals, and then you're going to set up your ratio, y over 40. Do a cross product, solve for y. Okay. We're going to look at some more slope triangles here that we're creating. So we already had our slope triangle with 11 degrees. And now we're going to create a slope triangle with some different degrees here. So the first one that we're going to graph is y equals 2/5. So if we're graphing y equals 2/5, that's like y equals mx plus b. And remember, the m, that's our slope. The b is our y-intercept. So these don't have y-intercept. They have nothing being added or subtracted after. So that means they all start at the origin, 0, 0, 0, 0. Okay, so for this first graph, we're going to go up 2 to the right 5. 1, 2, 3, 4, 5. Okay, I'm just going to erase these marks here. We can repeat that process. From this point, you can go up 2 to the right. 1, 2, 3, 4, 5. And then I'm just going to go ahead and draw a line that goes through it. You can, with a protractor, check the angle here. I'm going to go ahead and draw in a slope triangle. This slope triangle here being a 2 and a 5. The angle measure here is 22 degrees. And if we got a protractor out to measure that, we would determine that it was 22 degrees. So our slope ratio for this line is 2/5, up 2 to the right 5. You can also go, over 10 and up 4, right? So that would be a similar slope triangle, but that would simplify to 2/5. So we've got our slope angle 22 giving us a slope ratio of 2/5. So we first started with 11 degrees and 1/5. Okay, now we have a 22 degree angle producing 2/5 ratio. And let's look at our next one here. So we have 1/3, y equals 1/3 x. So I'm going to go up 1 to the right 3, up 1 to the right 3. We can continue that process. We're graphing that line. And then I'm just going to, from there, do the slope triangle that's the smallest. So that would be that 1/3 slope triangle. So that's this slope triangle here. And if we were to get out a protractor and measure this, this is 1, this is 3, we would get for this angle here 18 degrees. So our slope ratio for that is 1/3. And our angle measure is 18 degrees. Okay, and our last slope triangle, because then we're going to use these triangles to help us solve for some missing sides in other triangles that are similar to them. So now we have the graph y equals x. Well, if y equals x, that's basically like y equals 1x. So that means we can go up 1 to the right 1. Or whatever x is, y is also the same thing. So 1, 1, 2, 2, 3, 3, 4, 4, etc. So I'm just going to draw in the full line for that. This line ends up being pink. So now we have the full line y equals x. And I'm just going to draw the simplest triangle on that. It's going to be kind of small. It's going to be a 1 unit by 1 unit, 1 over 1. And then thinking about the angle measure that would create, we're basically taking a 90 degree angle and you're splitting it in half. So this is going to be a 45 degree angle, and the ratio is 1 over 1. Well, any number divided by itself is just 1. So I'm going to put a 1 there for the slope ratio. So we have our last triangle, 45 degrees. These two sides are the same. They could be 2 and 2s, 3 and 3s, 4 and 4s. I'm just going to put the simplest number there, 1 and 1. Now you're going to use these 4 triangles here to solve for the missing sides in these triangles. So for example, if this is a 45-degree angle, which triangle is that similar to? Okay, it is similar to this triangle. Therefore, what do we know about these two sides? These two sides here. You're going to use that to help you figure out the measurement for A. You can set up a ratio. Like you could do 1 over 1 equals 13 over A. Solve for A. Okay, we've got our 18-degree angle here. That's going to be similar to this triangle. So that ratio 1/3 should be equal to y over 14. 22-degree slope triangle is going to be similar to this one. You can set up a ratio. 11-degree slope triangle is going to be similar to this one. And then the last two problems, you're looking at, okay, well, what 20 over 50, what does that simplify to? Which triangle is that going to match up with? Therefore, what is the angle measure? And we call that, that's a little theta. Remember, that is theta. That's just a symbol for an angle measure. So you're trying to solve for what that angle actually is. Is it the 11 degrees? Is it 22 degrees, 18 degrees, or 45? Based on 20 being divided by 50, what does that simplify to? And then same here, what is the angle measure when you have two side lengths that are the same, 4 and 4? Okay, on to the last page of this lesson. We have that 11 degrees here in our slope triangle, but what that means is if we take 180, we subtract 11, we subtract 90, that's going to leave us with 79 degrees. So that's this other angle in our triangle, 79. And what ends up happening is, here's our 79 degrees. In the other triangle, this is where the 11 would be located. What ends up happening is this 5 and 1 end up flipping with each other. So when we have our slope angle 11, the ratio is 1/5. So 11 degrees, the ratio is 1 over 5. Remember, change in y over change in x. But if we look at 79 degrees, it's 5 over 1. So we can just put 5 over 1, or you can put that as 5 if you want as well. Okay. We have here, if we take 180, let's subtract 22, let's subtract 90. That's going to give us 68 degrees. Let's put that here. Our slope angle 22 degrees, our ratio is 2/5. Well, guess what? If we flip that triangle around, here we're going to have 68, and then we can put 22 here. And that 2 and 5 are going to flip-flop. So 5 over 2 is going to be our new slope ratio. Okay. So now we have 2 more triangles to kind of add to our toolkit. Go ahead and use the 68-degree slope ratio to help you solve for x in this triangle. So you're going to do 30 over x, and then you just have to figure out, okay, what do I need to set that equal to? Well, 68 degrees slope ratio should be 5 over 2. Okay. And then on this last one, you're going to do y over 15. And you're going to say, okay, y over 15, what does that equal? Well, it's a 79 degrees. So that's going to be 79. That's going to be 5 over 1. Okay. And then the last part here, we're going to imagine a 45-degree triangle. So here's 45 degrees. And here's my right angle. Okay. Now visualize what happens when you make this 45 degrees bigger. You're going to make it 55 degrees. So almost kind of visualize, oh, we're making it 55 degrees, 45. So you're explaining what side enlarges based on that. And then we're going to look at this really cool slope tool, because not only are we going to be able to use the slope ratios for the triangles that we can create, but we can use it for anything. So let's put that in bit.ly. And then we'll do slope tool. Oh, I already typed it in yesterday. So this slope tool, as you see here, this is right now a 45-degree triangle slope tool. Like this angle right here in the corner is, you can see, set to 45 degrees. You can watch what happens as we increase it to 50. 5 degrees. So that can help you confirm which side got longer in the process. Was it the vertical change in Y or was it the horizontal change in X? I'm just going to zoom out of that a little bit. Okay. And then you can also just see what happens. You can change the segment lengths of each of the sides just to see what happens. And if we look down here, we have a slope ratio of, that's our slope ratio. So right now that would be 1.428. Let's check what that was at 45 degrees. So here's 45. And you're noticing, oh, these two sides are the same. Like if this side change in X is 10, the other side would be 10. Our slope ratio is 1. Let's just check a few more. Let's do 11 degrees because we did that earlier. And you actually can just type that in. I'm going to put 11. And we got a slope ratio of 0.194. Well, when we did 11 degrees earlier, let's just kind of see what that simplifies to. That was 1/5. This 1/5 is 0.2, so that's very similar. This is actually a little bit more accurate, but it's close to that 0.2. Okay. Let's check what another one that we did. We did 22 degrees. 22 degrees, we got this ratio here. Well, we said 22 degrees, that was 2/5. So let me do 2 divided by 5. And that's 0.4. Good. We had 0.4 is 2/5. Oops, so if you look at our slope ratio, 0.4, that's very close, pretty accurate. Another angle that we did was the 18-degree angle. What is our ratio for that? It is 0.3. That's very close. It's 0.32 something, and that's very close to 1/3. 1 divided by 3 is 0.3 repeating. So these slope triangles here were all kind of derived from the whole numbers derived from these slope ratios here, these triangles that we created. So what you're finishing with in this lesson here, you're creating a 55-degree slope triangle. So here we've got our 55 degrees. We've got our change in Y is 325, and we've got this value here, change in X is what we're solving for. So remember, anytime in a slope ratio, you put these two numbers, so 325 over X, and what is our slope ratio for 55 degrees? Well, let's put it back to 55. And instead of having it as a fraction, like 1/3 or 2/5, it's just giving us a decimal. So this is going to be 1.428, and we're going to keep using 3 decimal places. So 1.428 is our slope ratio for that. Slope ratio for that triangle. Oops, for that triangle. So you can now take that decimal, 1.428, and you can equal it to 325 over X. And because this is not over anything, you could technically put it over 1, so you've created now a cross product for that.